Hello and welcome to part 7 in our training series. This is going to be a review of volume-based versus filtration-based water quality in detention ponds. So previously we have gone through a few things. We've gone through basic skimmer design based on volume. We've talked about advanced sediment basin design with SEDCAD. We went through a case study for permanent use of skimmers, to give you an idea why you might want to do that. And we've done advanced skimmer modeling and hydroflow hydrographs. Um, this one is going to be based on volume-based versus filtration-based water quality. And then in the future, we're going to have some water quality modeling on how we do volume-based versus filtration-based water quality modeling to help you with how you incorporate that into your design and projects. So first of all, let's talk about why we'd want to do this. So there's some flaws with using extended detention for water quality. So in general, basins are designed to capture pollutants by holding runoff for an extended time and allow for settlement. So typically there's a first flush volume in most areas that we're going to be required to capture. That ranges from an inch to maybe an inch and a half of runoff from whatever your site is coming to your pond. So basins that rely on settling time, they provide very little treatment for smaller storm events due to limited ponding and holding time. If we're going to base our volume on capturing an inch of runoff or inch and a half of runoff, and let's say we get a rainfall event of quarter inch or half an inch of rain over 4 to 6 hours, that's a really slow runoff into the pond. Therefore, we get very little ponding. And if all of our water quality is based on allowing time for things to settle, we're just not getting that under that scenario. So the other thing with that is volume-based designs result in larger pond sizes. And we'll go through that in our last series when we do some water quality modeling and show you how that works. But the way that's typically done really inflates the volume of ponds, and we're going to see that's not necessary to meet your water quality requirements. So there's some benefits to filtration instead of using settling or extended detention for settling. So the pond provides a large containment volume, and that's going to reduce the maintenance or frequency, and it's going to help treat larger drainage areas, even with a filtration-based model if we incorporate that into a pond. There's also excellent potential to retrofit older basins. So we've got a lot of basins in the country that were built before water quality requirements became a thing, right? And so those basins typically were designed just big enough to meet the quantity requirements. And so if we try to incorporate um, additional volume in there for settling to hold that for an extended period of time, the basins tend to overflow. So that's not really typically an option. But if we do it with filtration, and our filtration rate keeps up with that low storm event rate, so typically a 2-year storm, then that's an excellent potential to retrofit that basin to meet water quality. Then also filters in ponds are relatively easy to access and maintain. If you depend on how you put them in and what the system is. But if you compare that to an underground vault that requires confined space entry or some kind of specialty equipment, if we can incorporate a filter into a pond, we can get to it, right? So it's a little easier, doesn't require specialized equipment. So what are the benefits to filtration versus settlement? So first off, the peak rate of discharge from the pond can be based on the filter treatment flow rate up to whatever that first quantity storm event is. So typically that's like a 2-year storm in most areas. Some areas may have a smaller storm event that they look for scour control or erosivity or velocity kind of things. But in most parts of the country, what we see is that 2-year storm event is our first quantity storm. The other thing is that filter is going to treat 100% of runoff from storms up to the peak rate of the filter. And so if we can design that filter to handle, say, up to the 2-year storm event, and it's also treating those really low flow storm events that result in minimal ponding, we're now getting much more of the annual rainfall treated by that filter. Last thing is we can use media to be customized to target specific pollutants of concern. Hydrocarbons are a concern in some areas, and so filters can pretty easily to incorporate media that's going to absorb hydrocarbons that just simply settlement based would not do, right? Because the hydrocarbons are going to float, and they're still going to get discharged out of the basin whenever they get down to the orifice. But with a filter, we can customize that. We can also look at media that will absorb metals. Um, look at potentially antimicrobial stuff, maybe phosphorus and other, phosphorus and nitrogen kind of things for there, but um, those are a little harder to do. So again, basins rely upon the natural settling of sediment particles as they travel from the inlet to the outlet. So when you incorporate a skimmer, as we talked about previously in our permanent use, that skimmer is going to release the cleaner water from the surface. Again, it's widely accepted for construction, proven to be very cost effective. So it does make sense to use those same methods for post-construction water quality. So if we decide to add a filter to the skimmer, now you can size your skimmer to control that peak rate for that lower storm event. Again, that 2-year storm event is kind of what we typically see. The skimmer is going to increase the filter efficiency by withdrawing from the surface where the water is cleaner, right? So if we put our filter up here near the surface versus down the bottom, we're allowing that um, pollutants to settle when they can, when there's enough volume in the pond for it to settle, and we're taking that water off the surface. So our filter's not having to filter as dirty a water, so it's going to last longer. And then it's going to be easy to access. So, do your typical tie the rope to the skimmer or to the filter, pull it over to the side of the pond, easy to get to, or if it's a dry basin, just go out there after it's been discharged and take it out then. So, this is not a perfect system. There are some challenges to using skimmers with filtration. So, number one, filters are prone to clog over time, and they will require maintenance and periodic cleaning or changing. This is not a put it in and forget it system. It will require some maintenance, and we'll go through the details of that when we get into the specifics of the Rymar Water Quality Filter. Other thing is your skimmer's got to be durable, right, and last more than a few years to be suitable for permanent use. Um, Mainly we're saying don't use PVC, right? PVC and UV do not go well together. PVC is fine for temporary use for 2, 3, maybe 4 or 5 years, but we need a product that's going to last for 20 plus years. So recommend not using PVC. The other thing is, depending on the part of the country in, you may need alternate drains for frozen conditions. So if you're going to use a skimmer, if it's going to utilize that surface and you're in an area that gets a foot of ice, if you're in Minnesota or Northern Ohio or, Dakotas or wherever you may be that you get some major frozen conditions, you probably need to put in an alternate valve with a perforated riser to be used during those times. Hopefully you don't have to take the skimmer in and out of the pond. Kind of depends on your pond and potential for damage to it with being frozen. But most time, a smaller pond, we would say the skimmer should be durable enough to handle the frozen. And then lastly, the biggest challenge we have is there are no established standards for basis of design and permitting based upon the combination of a pond and filtration. Now, there are bases of design for filters. So typically they're looked at as a mechanical treatment device or MTD or some sort of proprietary device. Different MS4s have different regulations on those. Some of them have requirements to have certain approvals. Typically, there's a third-party testing requirement at a minimum. So you got to have some kind of manufacturer's data to base the TSS removal rate on. But that is part of the process. And so if you're an engineer looking at this and you're saying, hey, I'd like to use this um, in a specific area, please reach out to us. We will help talk to that reviewer, make sure they understand the basis of this, kind of the benefits of this. And when we get into the specifics about our Rymar water quality filter, make sure they understand how it works. So this is our prototype. So we had it installed to test adding a filter media around a skimmer. We were mainly focused on TSS. We know there's some potential for metals, hydrocarbons, and other pollutants, but this is, we've shown some previous videos, shown this pond where it's kind of our playground, our testing site, so to speak. So we've guinea pigged the product there. So this was probably our fourth or fifth version of this. And we went through a lot of testing to see how big the filters needed to be in order to keep up with the flow rate of the skimmer. This model basically has a turbidity curtain around it with like a screen. It's like a woven uh, polyethylene, polypropylene screen, like a Mirify type fabric. And then this inner material is a non-woven. It's called Adsorbit. And it's what we used as a second stage to kind of polish the water that's coming through. So where we put this is, it's called the former Simpsonville Chevrolet. It's now a different, being used as something different than the car lot, but it is been monitored for over 24 months to monitor how the filter works. And one thing to point out, as you can see in this picture, is a lot of trash gets in this pond. So this has maybe a 30-40 acre watershed. It's in an older commercial area. The majority of the area does not have stormwater management in place. And so get a lot of junk and trash in this pond. So if the filter works here, we're pretty confident it's going to work in most other locations. We had our field testing done. We monitored it, looked at turbidity. It's definitely, you can see a difference in turbidity on the outside of the filter versus at the skimmer. And then this right pictures the actual outfall. You got to say that's pretty clean water coming out of a pond, right? Probably wouldn't drink it, but definitely a lot cleaner than what was in it. And we've now had third-party testing done to an ASTM standard, and our testing confirmed 90% TSS removal using this combination of skimmer filter system. So one thing to point out about our testing, it was done in a lab. TRI Environmental did this. They tested two versions of the skimmer. That's part of the ASTM standard requirement. You got to have two tests with a significant difference in flow rate between the two tests. Basically, one skimmer flows about double the other. The other thing to point out is that the water was introduced into the tank right at the filter. So, here's where the water's coming in. Here's the first filter. That's about a foot, foot and a half separation. So essentially, we took out the benefit of a forebay. We took out the benefit of travel distance from an inlet to an outlet. And so this test was sort of well, not sort of, it was a worst case condition for testing the filter to see what it alone could do, not taking in the benefits of a typical pond that is going to get some of the pollutants taken out before it gets to the outlet. And it was modeled as a dry pond. So we started off with the tank empty, filled it up, kind of went through a cycle, and then drained it out and did the testing that way. So the testing results were both versions achieved greater than 90%. I believe technically the smaller version achieved 96%, and which was like a 2-inch skimmer with a 1.5-inch orifice, and then we tested our 4-inch skimmer with a 4-inch orifice, and it got like 92%. So both achieved 90% or more TSS removal for that. Since then, we have installed our commercial version. So this is that pond where we did the prototype. You can kind of see pretty big pond, a lot of stuff floating around in it. This is the skimmer and filter once it is drained down. So this is using our current skimmer version, our 4-inch skimmer, and this is the pretty close to the commercial version of the filter that we plan to have available. We've got a time-lapse camera set up here to monitor it, so we keep an eye on things and make sure it's working. We're going to monitor this for the next several years. Just keep this filter in there just to see exactly how long it lasts. We're predicting a minimum of 2 years, which is what our maintenance schedule is right now. But we'll see, how much longer it lasts and how effective it is through the seasons. So that is our summary on volume-based versus filtration-based water quality. The next step is going to be going through a model to show how that would work in, when you compare modeling it volume-based versus filtration-based, and look forward to that one soon as well. Thank you for watching. If you'd like to receive continuing ed credit, please email us at info@rymarwaterworks.com. Or if you just have any questions about this, you can email us. And again, we've talked about it before, but if you go to our website at marleefloat.com or rymarwaterworks.com. Go to the engineering page. There's an engineer's spec pack, which has all of our details, testing, design guidelines, etc. there for you. Make it really simple. Thank you for watching.